Our discussion with respect to the introduction to databases. So these are the topics to be covered as part of today's presentation. So some common applications of your database systems. So what is the definition for the term database as well as your database management system? So if you are going to create a database, do you have any constraint with respect to your size and the complexity? And if you want to create a database, who is responsible for creating a database and who is responsible for maintaining the database? What is the difference between the term database and database management system? So if time permits, I will introduce the limitations with respect to the traditional file processing system. Now, to start with, how can you give me your answer for this question? Is it possible to store a database in your primary memory? One of you can unmute your mic and you can give me your answer. Anuradha Shri. Anuradha Shri.
No, sir.
Can you tell me the answer for this question?
Sir, I don't think so, sir.
Louder, please.
Sir, I don't think so, sir.
No, you don't know the answer or whether the answer is yes or no.
No. No, sir, no.
It is not, so according to you, it is not possible to store the database in primary memory.
Yeah, sir.
Okay. What about Anantullah Shashidhar?
I think no, sir.
Do you agree with my statement? Whether it is
No.
possible to store the database in your primary memory or not?
No, sir, no.
No. Okay. So any other opinion? So whether some of you consider it is possible to store the database in primary memory?
Sir, it might be possible, sir, but it is of no use.
Balakumar, come again?
It might be possible, sir, but it is of no use, sir. It will get erased anyway.
No. See, basic question is don't bother. See, that is the inherent capability of your primary memory. So it is volatile. My question is, the idea is it possible to store your database? Whenever we use the term database, so if you recall the concept what we have discussed as part of the last lecture, you are going to store huge volume of data. So my question is there any chance for storing the data in your primary memory?
I think we can, sir.
I agree with you. The limitation in your primary memory is if you close the program or if the power goes off, the content will be erased. I am not talking about your durability, reliability and all. Simple question is whether it is feasible.
Space won't permit, sir. So it might not be possible, sir.
Okay. So I will give you the answer for this question in slide number 7. While explaining the real-time database, I will give you the answer for this question. Okay. So now, in our modern society, your database and database system has become an essential component in your day-to-day life. So don't get confused. These two terms are not same. Your term database differs from your database system. So your database system is nothing but a what? Database system is a combination of your database plus database management system. Your DB plus DBMS put together forms the database management system. So, as part of our day-to-day life, knowingly or unknowingly, we people encounter several activities that interact with a database. So I will give you some common application where you are interacting with the database. Now, if you go to a bank and if you are going to perform a deposit or withdraw operation, or you want to perform a reservation in a hotel or in an airline, you are having a computerized library. You want to search for a particular book, whether the book is available or not. Or you want to search for a particular thesis, or you want to search for a particular bibliographic term with respect to that particular library. And another familiar environment to you, you are performing some online purchase. So in the first, so here I have listed 5 applications. So the last term is what? So physically you are going to a supermarket, you are purchasing an item. In that case also there is a chance for interacting with an database. So what is the difference? So if you take the first 4 examples, what I can say is directly. So if you are performing some online transaction, so you are performing all these operations using internet. So in that case, what I can say is directly you are interacting with the database. Whereas if you take the last example, so you are not going to interact directly, but you are going to purchase an item. So automatically that item, so the inventory of the supermarket will get updated. Updated means the quantity will be reduced. So the final one is an example for what? The final one is an example for indirect interaction with your database. So the first 4 categories, I can call it as a what? Direct interaction with your database. Now, so if you take these database application, you can call these database application, or you can group these database application as a traditional database application. So if you take a traditional database application, what is the limitation? So what they say is, if your application is going to be a traditional database application, or in the case of a traditional database application, the data is stored either in the form of a text or numeric. In the case of a traditional database application, you are going to have only 2 types of data. Either it may be a text data or it may be a numeric data. Now, with respect to modern database application, or with the advancement in technology, nowadays what we can do is, so I can construct a database for storing different types of data. So for example, I want to store some picture, or I want to store some images, videos and sound. So if I create a database for this purpose, then that particular database is called as your multimedia database. Okay, so this is the deviation from your traditional database application. Okay, so in the case of traditional database application, data will be stored either text or numeric. Now suppose if I am going to call my database as a multimedia database, in that case, so what will be the content, or what is the data stored in the, what is the type of data stored in your multimedia database? It may be in the form of it may be an image, or it may be a video, or it may be a sound. You can have a database associated with your geographical information system, database for your geographical information system. So in that case, what type of data you are going to store? So in this case, I want to analyze the data, or I want to analyze the images. So with respect to your weather, so you are going to store some weather data. So mostly if you take geographical information system, so the data is, so the thing is, now you may ask a question, so what is the difference is, so here also you are going to store an image, here also you are going to store an image, but the difference is what? Size of the image. Okay. So next type of database is, so another terminology is called as data warehouse. So your data warehouse is not same as your database. Okay. So the thing is, if you take an organization, the top level person in an organization needs to make some decision. So when to launch a particular product. So like that, they need to make a particular decision. So for that, they need some historical data. So if I want to store a historical data, I'm going to construct a database, and if my database is going to have, or if my database is going to store the historical data, then I will not call it as a database. Instead of that, I will use the term as the data warehouse. So from a data warehouse, if I want to retrieve some information, I need to perform OLAP, online analytical processing. Whereas with respect to your database, you will be performing OLTP, online transaction processing. So what is the difference is, your database is used to record day-to-day transaction. So if you take a bank database, so with respect to 1st March, so what is the information stored in the bank database? So what are the withdrawals, what are the deposits? So these information will be stored in your bank database. So your database contains the recent information, or your database contains the day-to-day information. Your database is used to record the current data. Whereas in the case of a data warehouse, you are going to have some historical data. So another type of database is called as the real-time database. So I need to create a database for controlling the industrial and the manufacturing process. So that type of database is called as real-time database. Now, so what is the difference is, so I have started today's lecture with a question. So here is the answer for this question. So if your database is going to be a multimedia database, or it is going to be a GIS database, or it is going to be a database related to the traditional applications like bank database, reservation database, computerized library and all. So in that case, it is not feasible to store the data in your primary memory. Always the data will be stored in your secondary memory. Whereas one uniqueness with respect to your real-time database is, so your real-time database, the thing is, what they are trying to say is, the application is going to be very, very small. You are going to address a very special, you are going to address a particular issue, and that particular application scenario is going to be very, very small. So the size of the data is going to be very, very small. So in that case, you can store the data in your primary memory. So if your database is for a real-time application, then in that case, the size of the data is going to be very, very, very small. So in that case, in order to increase the speed, what you can do is, you can store the data in your primary memory. So in general, what we say is, whenever we use the term database will be stored in your secondary storage device. So immediately don't come to the conclusion, it is not possible to store the database in your primary memory. So the answer depends on what? The answer depends on the application and the volume of data. So if you are going to use the database for a limited purpose, limited time, and for a specific application, in that case, it is feasible to store the data in your primary memory. So next. So now I need to highlight the difference between your database and the data warehouse. So you are having, so here I have given the link. For further information, you can refer that link. So the thing is, I want to touch the difference between the database and the data warehouse. So if you take the database, the specific purpose of the database is to record the data. So why you are storing the data in a data warehouse? We need to perform what? We need to analyze the data. If you want to analyze the data, store the data in a data warehouse. So another thing, you may ask a question. So what another major difference is, here you are going to have a predefined structure. Here you can have a what? So here, whenever we use the term database, the data is of homogeneous data. Your database contains the homogeneous data, whereas your data warehouse may contain heterogeneous data. So what we need to do is, you need to perform some data transformation. So as of now, don't bother about that. So I want to highlight the difference between your database and the data warehouse. So you need to be familiar with these two terms, OLTP and OLAP. So online analytical processing and online transaction processing. So the operations related to your database comes under the category called as OLTP. So operation related to your data warehouse is called as OLAP. And another thing is, with respect to database, mostly the dimension is restricted to what? 2. So the data will be stored in a what? Data will be stored in the form of a table. Whereas if you take a data warehouse, it is used to what? It is used to visualize the data in a multiple dimension. So usually the data is stored in a multi-dimensional format. So what we will do is we will perform a slicing operation. Okay, so for extracting and all pivot, slice, like that, we will be using different types of operations. That comes under the category called as OLAP. Okay, so and another thing is, so what is the advantage in the case of a data warehouse? So your data is not going to be normalized. So extracting the data, so in this case, in the case of database, you are going to have multiple tables. Each and every table is going to be normalized. So fetching the data from multiple tables requires some time. So you need to develop some complex queries. So if you are going to have multiple tables and performing a join operation such that extracting join, what is the role, what is the use of the join operation? Join operation is used to extract the data from multiple tables. So performing a join operation, it requires some time. And with your database is related to what? It is related to a particular application, where it is related to a particular subject. So for example, your subject may be a what? Your subject may be a customer, it may be a product, it may be a company. So here I have highlighted only some few differences between database and the data warehouse. So for additional information, so I have taken this snapshot from this link. So if you want, you can use this link to further explore the difference between the database and the data warehouse. So usually the data is relevant to a particular context. So now here, what is the context? So here, so in this figure, I have given a data related to a particular course. So what is the name of the course? Name of the course is MGT 500. Name is going to be business policy section. So student name, ID associated with the student, what is the major, and grade point, average, so all those things. Okay. So now here simply you are going to have a what? Data. So how to extract the meaningful information from this data? So for better understanding, if you are going to extract, if you are going to represent this particular data in a graphical format. So if you are going to see the same data is represented in a graphical format. So if you are going to represent the data in the graphical format, so you can extract some meaningful information. And this information can be used by the high level people or the top level people or for the managers for performing some decision making. Okay, so these are based on the past data. So the thing is what? So what is the estimation? So this is the diagram I have taken. So you are having the year maybe what? Year may be very good. But now what I want to highlight is, so how to extract the meaningful information, or if you represent the data in a graphical format, then it turns to what? Then it turns to meaningful information. That information can be used by the appropriate persons to take decisions. Now, so how will you define a database? What is the trivial definition for a database? So your database is nothing but a what? Collection of related data. Next down, how will you define a data, or what do you mean by data? So your data is nothing but what? So your data is a collection of facts that can be recorded, and it is going to have some implicit meaning. So for example, if I want to store the name, telephone number and address of my friends, I want to create a contact management list. So I want to store the information that related to what? Name, telephone numbers and address. So now what are the various options you have? Nowadays, in the mobile phone itself, you can store the data in your mobile phone. So for this purpose, so if you are going to store the data, automatically it will be sorted. If you want to perform a search, if you want to perform edit, for all these things, you are having a what? You are having a support in the software that is available in your mobile phone. So this is an example for what? Somewhat automated contact management system. So what is the other option? So I don't have a mobile phone. But nowadays it is not possible. So the thing is, suppose I am not interested in storing the data in a mobile phone. So I want to create a manual database. So in that case, you can create an index-based address book. So A, B, C, D, like that, you can have various index, and according to the name or according to the starting letter, you can store the data in the index book. Or suppose I don't want to use a specialized software. So simply what you can do is, if you are going to use a laptop or if you are going to have a personal computer, so you can use the general word processing software or Excel sheet. You can record the statement and you can store it in what? You can store it in the secondary storage device. So these are the various options you have in your hand for creating the database or for storing the data. Now, so if you see the definition for the database, so you are going to have collection of related data. So what they are trying to say is, see, suppose you are creating a table called under, for example, the name of the table is going to be student. Then you are storing some data. So all the records should be related to what? Related to your student. So it should not what? So first record is going to be information about the student. The second one is information about a mobile phone. Third one is information about a textbook. So that is not the case. So here, whenever you are going to create a table, you are going to store the related data. So that is the idea. So you are going to have some implicit properties associated with the database. So your database is nothing but a what? Logical, coherent collection of data. So you are going to have some inherent meaning associated with your data. So each and every database is designed, built and populated with data for a specific purpose. Or for each and every database, you are going to have a specific targeted audience. And whenever you are going to create a database, it resembles some real world application or some concept that exists in the water, that exists in the universe, or that exists in the real world. So in other words, simply what I can say is, whenever you are going to have a database, so for the database, you are going to have the source. Each and every database is associated with the source. So what do you mean by the source? The source from which it is going to get the data. And it is going to have some interaction with the what? It is going to have some interaction with the real world events. And it is going to have some group of users, or it is going to have some targeted audience who are very much interested in the what? Who are very much interested in the content that is available inside that particular database. So these are some concepts related to your basic definition with respect to your database and the data. So next idea is with respect to the size and the complexity. So now you are interested in creating a database. Do you have any limitation with respect to the size and the complexity? So if complexity means inside the database you can have only 3 tables, or in the table you can have only 4 fields or 5 fields, like that. So general answer is, you don't have any limitation you don't have any limitation on the size and complexity. So according to the application need, you can create a database of any size and complexity. So but practical limitation is what? So the size is what? From the application point of view, you are not going to have any size, but literally the size will be determined by your secondary storage device, or your what is the storage capacity you have. Now again, so we will take some few examples and we will try to identify the size and complexity associated with that particular database. So if you take our previous example, if our previous example related to storing the name and address of your friends, or name and address of your some persons. So in that case, the size is going to be very less. So at the maximum, you can have some 100 entries or 200 entries or 300 entries, depending upon your contact levels. So whereas if you take a computerized library, sorry, if you take a computerized library, so in that case, if the library is housing huge volume of books, so in that case you may be having what? It depends on the library size and the volume of books. So in some situation you may be having what? The entries may be in lakhs or it may be in thousands. Now, you imagine the database that is maintained by your Facebook and the Twitter and all. So nowadays, every person, okay, so the database associated with your social media. Most of you people are very active in the social media in giving some comments and posting your opinions and that. So in that case, you cannot determine the water, you cannot determine the size. So the complexity and the size varies, depends on the water, varies, depends on the application. One simple thing what they say is, if you take a commercial database used by your Amazon, so the commercial database used by your Amazon.com, so you can imagine, okay, so what will be the size of the database? So how much information is stored inside the database? Now in that case, what you have to infer is, so with respect to your Amazon database, it is not possible to store it is not possible to have a single database. The thing is, you may be having multiple tables, but it is not feasible to store the database in a single location. So you need a your database is distributed and it is scattered in various or in different location. And we are going to refer it as a what? We are going to refer it as a server. So your database is stored in multiple servers available across the world. So you are not going to have what? You are not going to have a centralized database. In that case, so if the volume of the data is going to be very, very large, in that case your database may be what? Your database may be distributed. Next idea is, who is responsible for creating the database and who is responsible for maintaining the database. So again, based on the previous examples, you can come to the conclusion that you are having two options. Either your database may be created by a person, or your database may be a manual database, or it may be a what? It may be a computerized database. So the discussion related to these topics is what? So the thing is, you don't have a you don't have a concrete option. So it depends on the application. That is the final conclusion. If the size of the database is very small and the users is going to be very less, in that case you can maintain the data manually. So if you want to allow multiple users to access the database and the volume of data is large, then in that case you can go for a computerized database. Now, if you are interested in creating a computerized database, so what is the option you have? So if you want to create a database according to your need, what you can do is you can create your own database. Or for general purpose, you are creating a database, means what you can do is you can utilize any one of the existing database management system and you can store the data in the particular database. So next idea is about database management system. So for our discussion, so what are the things I have explained so far is related to the terminology database. So what is a database? Collection of related data. How will you create a data? So it is going to have some properties. So what are the properties? Okay. And another thing is, what about the size and complexity of the database, and who is responsible for creating and maintaining the database. So next idea is with respect to database management system. So actually this figure shows the various components that is available inside your database management system. So in the, see here, so this is your actual database. So you can visualize this as a what? A hierarchical structure or a layered architecture. Okay. So in the topmost level, okay, or in the top layer, your user. So the thing is, so here you are having the user, here you are having the database. So what is the need? The users in the top level need to interact with the database that is available in the lower layer. So what the user is going to do, user is going to make use of certain application programs. So user makes you see here the thing is what your database plus database management system put together forms a database system. So your programmer or your users make use of the application programs to interact with the database. So another distinct difference with respect to your database. The thing is, so in the case, so how your database differs from your file processing system. So if you are going to represent, if you are going to have a diagrammatic representation for your file processing system. So for example, see here, this is an example for your traditional file processing system, payroll, employee file, account payable program, vendor file and the invoice file. So now what is the difference is, see here, for a payroll program, you are having one specific file. Whereas in this database, see here, so for this database, each and every database, the structure, so you are going to have, you are going to store, along with the database, you are going to store some additional information with respect to this database that describes the structural information related to this database. And we are going to refer this additional data as the metadata. So this is not your actual data. Your actual data is stored in the database. Data about the data is called as what? Data about your database is called as the metadata. So the thing is, whenever you want to fetch the record, first the required information will be fetched from the metadata, and it will be the relevant data. After fetching the required information, the relevant data will be extracted or it will be fetched from the database. So user will supply a query. So what you need to process the query, and you need to identify the data, and then you need to extract the data. So now you are having various components available in database management system. So now, yes, typical definition for a database management system. How will you define a database management system, or what is the basic purpose? Why do we need a database management system? Your database management system is a computerized system, so that is used to create and maintain the database, or that allows the users to create and maintain the database. So what is the role of your database management system? Your database management system is a general purpose software system that is used to define the database, construct the database, manipulate the database, and share the database. So what is the steps or what is the operation you need to perform with respect to each and every process? So if you want to define a database, so what are the steps involved in defining a database? So you need to identify the data type associated with each and every field. Suppose if I want to store the information about student, what is the data type for register number? What is the data type for name? What is the size for your register number? What is the size for your name? Size for branch, size for gender. So all those information you need to finalize. And do you have any constraint? So your name should be 30 characters, or all the names should start with some particular character, or your register number. So it should be only number, and it should be greater than 0. And you suppose if you are having marks and the maximum digits is 3, it should be greater than 0, and it should be less than 100, like that. You can have some constraints. So all these information, so as I have told in the previous slide, all these information will be stored in the metadata or stored as metadata. So that is called as your DBMS catalog or dictionary. So what is the role of this DBMS catalog? Your DBMS catalog will have the information about the database, and we are going to refer that data as the metadata. So constructing the database, you can use a language. Constructing means storing. So where you are going to physically store the data, and what is the data structure you are going to use for storing the data in your secondary storage device. So after creating the database, how to interact with the database, that is with respect to your manipulation. So you want to retrieve some specific data, or already you have stored some data, you want to modify the data. So modification is nothing but the updating the data. So based on the data that is available in the database, you need to generate some reports. You want to generate reports with respect to various conditions. So these three operations, querying, updating, and generating reports, comes under the category called as manipulating a database. So what is the requirement is, your database management system should provide support for performing all these operations. So what are the operations? For constructing a database, for defining the database, constructing the database, manipulating the database, and suppose if you want the data to be shared. So how to share the data among multiple users without any conflict? So one module in your DBMS is called as concurrency control mechanism. So the concurrency control mechanism is used to avoid the conflict. Now you need to protect the data that is available. So for protection also you are having the protection as well as recovery. See, you are executing a transaction. In the middle of the transaction, your system fails, or you are having a error in the middle of the transaction. So abruptly you cannot abort the transaction. You need to restore the transaction to a safer state. Or if you want to continue with the transaction, you need to You need to continue with the transaction. You need to redo that particular operation. So in some cases you need to perform undo operation, and in some cases you need to perform redo operation. So how to protection? Broadly you can classify the protection into two things. One is system protection and security protection. System protection means how to protect the data from your hardware and software malfunction. So your data is stored in your secondary storage device. You may be having some bad blocks, or that particular sector may get corrupted. Suppose there may be a error in your software. It may be it may be fetching the irrelevant data that is not related to your current query. So you need some mechanism to handle all these scenarios. Security protection means you need some authorization mechanism. Only valid users are permitted to interact with your database. If your database is going to have some sensitive data or some confidential data or some private data, in that case you don't want the database to be public, exposed to public. So you want to group the users, okay, into low level users, high level users, okay, or normal users, admin, like that. You want to categorize the users, and you want to assign different privilege for different user groups. That is with respect to your protection. So basically, one major requirement of your database management system is with respect to what? Maintenance. It should provide support for maintenance. See, whenever we create a database, your database is associated with a life cycle. So life cycle means once you create a database, that database is going to exist for years together. I am not going to create a database for 1 day or 1 week or 2 days or 3 days. So you are going to create a database for a particular application. The usage of the application, that particular application may be used for years together. So the thing is what? Initially you might have designed a database based on a requirement. Subsequently, you want to add some additional functionality to that particular application. So your database management system should provide support for modifying the structure of the database. So whenever the requirements changes, so your system, your DBMS, database management system, should allow the users to modify or to incorporate the new specifications to the existing system. So this terminology already I have explained. Your database and database system put together is called as your database system. So your database management system may be a general purpose, or it may be designed for a specific purpose, or for a specific application, or for a special purpose. So based on that, you can classify that database management system as a general purpose database management system or special purpose database management system. So this is similar to your, you might have studied about hardware evaluation and all, starting from vacuum tubes to your ICs. So like that. So this slide is used to highlight the evolution of database. So we have started in early 70s and 75s. We have started with the relational database. Then we moved to distributed database, multi-dimensional database, object relational, object-oriented, multimedia database, intelligent database. Now, recently, starting from 2000, 2005 and all, we have our focus is on what? Data warehousing, data marts, and current lot of research is going on in this field, data mining. And nowadays, since everything is automated, our major focus is on database related to your web-based application. The same information represented in the form of a graph. So initially, they have used magnetic tapes for storing the data. Then they have started storing the data in files. Then they moved to what? Hierarchical model, relational model. So here they have started storing the data in an entity relationship model. So now we are having what? Different models. So nowadays we are interested in storing the data related to what? Web-based, and we are interested in constructing data warehouses. That is starting from 2000. So quickly I will highlight the concept related to your traditional file processing, or what is the major limitation in your traditional file processing system. So I think this I have highlighted in the last lecture itself. Okay. So this is a diagrammatic representation related to your file management system. So the thing is, see here you are having some 4 or 5 users. One user is using the billing program, another user is using the accounts payable program. So here also you are having a purchase program. So now what is the similarity you have noticed? 2 different users. See here, this user is also accessing the vendor file. This user is also accessing the vendor file. So now if you visualize this from your C programming language, suppose if I give you an application, if I ask you to create a file for that, you will create a structure. So that structure is closely, so where will you create a structure? You will create a structure as part of your C program. So your that is your data and your program is what? Tightly coupled. So that is the limitation in your file processing system. So if you want to modify the program, you need to modify the structure. And if you want to add one more additional field, the existing program will work, but it will not give you the expected result. So you don't have physical data independence and the logical data independence with respect to your file processing system. So with respect to file processing, if you take each and every user, so they define the file. They define their own requirement and they will try to create a file according to their requirement. And the structure related to the file or structure related to the data, what you are going to store in that file will be stored as part of your program itself. So you take one standard example. So your university, okay, so you are having 2 departments. One is your grade reporting office and another one is your accounting office. So here also, so the thing is what? The information is stored in the form of a file. So the thing is, so same data is repeated or same data is stored in more than one location. So what is the major limitation? You are going to have what? Redundancy. So the major limitation with respect to your file processing system is redundancy. So if you take this scenario, you are having 2 users. One user is in grade reporting office and another user is in accounting office. Even though both the users are interested in using the data related to students, but each user maintains the separate file. They are going to use a separate C program. So what is the reason? So certain data is not available in another location. So for example, so here there is information about the fee payment is missing. So if you take from this point, information about their grade may be missing. So the major problem is each and every user, they have finalized the structure of the data according to their requirement. So that is the major limitation with respect to what? Major limitation with respect to your file processing system. So major limitation is data redundancy, and you need to perform the same operation more than once. So that is the limitation in your file processing system. Because of that only, from the traditional file processing system, we have moved to what? We have moved to database systems. So with this, I will stop today's lecture. So thanks for your participation. If you are having any doubt or if you need any clarification, you can ask me. So if you see the today's presentation and if you compare the content in your textbook, I have covered only the first 2 pages from the first chapter.